And welcome back. As we continue our journey around the sun, let's go ahead and take a moment to examine solar activity above the photosphere. So one of the very first thing is this idea of plugs. Emission lines of hydrogen and calcium are produced in the hot gases of the chromosphere. Now pictures taken through these special filters show bright clouds in the chromosphere around the sunspots known as plugs. These are actually regions within the chromosphere that have higher temperature and density than their surroundings. The plugs contain all the elements in the sun, not just hydrogen and calcium. And it just so happens that the spectral lines of hydrogen and calcium produced by these clouds are actually very bright and relatively easy to observe. The next thing to discuss is prominences. Now, if we move higher up into the sun's atmosphere, we come to the spectacular phenomena known as prominences, which usually originate near sunspots. Now, eclipse observers often see prominences as red features rising above the eclipsed sun and reaching high up into the corona. Now, some, which we refer to as the quiescent prominences, are graceful loops of plasma that can remain nearly stable for many hours or even days. The relatively rare eruptive prominences appear to send matter upward to the corona at very high speeds, and the most active surge prominences may move as fast as 1,300 kilometers per second. Now, some eruptive prominences have even reached heights of more than 1 million kilometers above the photosphere, so it just shows to show you how disruptive our sun actually is. So let's take a look at some of those prominences, and again, how they can appear when you're observing the sun. If we look at image A here, we can see the image of an eruptive prominence that was taken in the light of a singly ionized helium in the extreme ultraviolet part of the spectrum. Now, a prominence in image B here is a huge cloud, relatively cool, about 60,000 Kelvin in this case, fairly dense gas suspended in the much hotter corona. Now, these pictures, remember, are not in visible light. Instead, they're actually taken ultraviolet, and they've been color coded so that white corresponds to the highest temperatures and dark is corresponding to the cooler ones. But one of the interesting things you can see, if we look at image A, for example, just the size of this prominence loop here, and just the Earth to scale. So we could very easily have Earth pass through here, just to give you just how big this loop is in comparison to the sun itself. Now, while we're talking about loops and stuff like that, we need to discuss solar flares. The most violent event on the surface of the sun is a rapid eruption called a solar flare. Now, a typical flare lasts anywhere from about 5 to 10 minutes and releases a total amount of energy equivalent to that of about 1 million hydrogen bombs. Now, the largest flares last for several hours and actually have enough energy to power the entire United States at its current rate of electrical consumption for about 100,000 years. Now, near sunspot maximum, small flares occur several times per day, and major ones may occur every few weeks. Now, there is an extreme to solar flares, which we refer to as coronal mass ejections. Flares seem to occur when magnetic fields pointing in opposite directions release energy by interacting with, and destroying each other. Just think about this as a stretched rubber band that is releasing energy when it breaks. What is different, though, about flares is that their magnetic interactions cover a large volume in the solar corona and release a tremendous amount of electromagnetic radiation. In some cases, immense quantities of coronal material may also be ejected at high speeds. We're talking about 500 to 1,000 kilometers per second into interplanetary space. And we refer to such things as a coronal mass ejection, and these can affect Earth in a few ways. Now, the sun has active regions in which that we tend to monitor these different areas, such as flares, coronal mass ejections, etc. Sunspots, flares, and the bright region of the chromosphere and corona tend to occur together in the sun in the time and space. So when we are looking for these different things, it kind of gives a clue to where we might expect them to occur. Now, they all tend to have similar longitudes and latitudes, but they're all located at different heights in the atmosphere. Now, because they all occur together, they vary with the sunspot cycle. Flares are much more likely to occur near sunspot maximum, and the corona is much more conspicuous at that time. A place on the sun where a number of these phenomena are seen is called an active region, which is always associated with strong magnetic fields. So you get a lot of correlation here between magnetism and solar phenomena.